Hi, this is Michel Birler. We will see together how to estimate a nested logit model using PythonBiogeme. If you go on the Biogeme webpage, you will find under example indicators the documentation about the data file that we will be using in this video. Let's have a look at the Python file that contains the model specification. So we will estimate a transportation mode choice model containing three alternatives. One would be car, the second would be public transportation, and the third would be slow mode, which means walking or biking. We will be estimating 8 parameters, 2 alternative specific constant and 6 coefficients for the variables. In the next section, we have the definition of some variables that will be used in the utility functions. First, we scale some variables from the data file. For example, the time in public transportation, which is called time pt in the data file, is divided by 200 so that we manipulate lower numbers in the specification. The new variable that is created like this is called time pt scale to emphasize the fact that it has been scaled. Then we define a couple of socioeconomic characteristics from the data file, male and female to identify the gender of the respondent. Some respondents didn't report the gender, so we will have variables called unreported gender. And the second set of characteristics is the status of or a job occupation. We have full-time for people who have a full-time job and not full-time. Next, we have the specification of the utility function. The utility function for public transportation contains the travel time and the travel cost. The travel time is interacted with the job occupation. Same for the car. The difference now is that we have an alternative specific constant for the car. The one for public transportation has been normalized to 0. So we have again the travel time interacted with the job occupation and the cost. For the slow mode, we have also an alternative specific constant, and then we have distance interacted with gender. We then associate each utility function with a number, with an ID corresponding to the ID in the data file, 0 for public transportation, 1 for car, and 2 for slow modes. Then we specify that all alternatives are always available, so that the availability of each of them is 1. And then we define the nests. In this specification, we will group together the two alternatives which are not car. So we will put car alone in one nest and the two other alternatives in another nest called no car. We define the nest parameter that will be estimated for the second nest as nest no car. And then we associate the list of alternatives to each nest. So the nest car contains only one alternative, which is alternative 1, and its nest parameter is 1, which is fixed because it's a trivial nest containing only one alternative. The second nest, called no car, contains two alternatives, alternative 0 and alternative 2. It is associated with the nest parameter nest no car, which has been defined above. We put the two definitions of the nest together in the variable nests that will be used in the calculation of the nested logit model below. The next statement tells Biogeme to exclude all observations such that the choice is equal to -1, which would mean that the respondent didn't specify a choice and the observation cannot be used for estimation. The next statement is actually calculating the formula of the nested logit model as a function of the utility function, the availability, the definition of the nest, and the choice which has been reported by the respondent. The output of this formula would be the log of the probability of the nested logit model, which is basically what we will need as a contribution for the likelihood function. We define an iterator on the data, and then we can calculate some statistics. In addition to the classical statistics calculated for the estimation of choice model, we ask also PythonBiogeme to report the number of males, number of females, number of people who have not reported their gender, the number of people who have a full-time job, and also to calculate the sum of weights in the sample. And this will be handy when we will calculate market shares. And the final statement tells PythonBiogeme to estimate the model using for the likelihood function the sum of the log probability of the nested logit model over the data file. So we are now estimating the model. We type PythonBiogeme, then the name of the model, which here is 01 nested estimation, and then the name of the data file, which is optima.dat. And then PythonBiogeme is running the algorithm to estimate the parameters of the model. Once it's done, PythonBiogeme is reporting the list of files that have been created. And there are two important files. One is the file .html, which contains in HTML format the results of the estimation. And the second one that we will use actually for simulation is the one with the name _param.py, which basically contains the results of the estimation in Python format. The file with the extension HTML can be opened in any browser of your choice. This file first reports some information about the version of PythonBiogeme that you have used to estimate it. Then it lists the name of the report file and the sample file. The next section reports statistics that have been requested by the user. So here we can find as requested the information about gender and about occupation, as well as the sum of weights. The estimation report first provides some statistics about the estimated model, and then some information about the optimization algorithm that has been used to estimate the parameters. The next section contains a table reporting the estimated parameters. In front of the name of each parameter, you find the estimated value, the estimated standard error using the Rao-Kramer bound, the associated t-test, and the associated p-value. If the p-value is equal to 0.05 or higher, a small star is included in the next column. The same values are also reported using the robust estimation of the variance-covariance matrix. And again, you find the standard error, the t-test, and the p-value that are estimated using this second method. Similarly, a star will be included in the last column if the p-value is equal to 0.05 or higher. The next section reports information about the correlation of coefficients. For each pair of coefficients, the estimated covariance is reported, the estimated correlation, the t-test that tests the assumption that the two coefficients are equal, and the associated p-value, and the same information using the robust estimates of the variance-covariance matrix. Note that these pair of coefficients are sorted in decreasing value of the p-value. Finally, the very last information in the estimation file is the smallest singular value of the second derivative matrix of the log likelihood function. If this value is close to 0, it means that the model is not identified. And in this case, PythonBiogeme will provide some hints about the cause of this misspecification. So this gives you the basic information to understand the specification of a discrete choice model in PythonBiogeme. Now what you need to do is to test it yourself. So go to the PythonBiogeme webpage, pythongeme.epfl.ch, download the files and try it yourself.